Hi, geometry. So what I've got in front of me is the assignment worksheet that you were assigned this week in Canvas. I'm going to go over a few of the problems so that hopefully you can do the rest by yourself. It's got the AA similarity that'll help bring up some of your grades if you do this and the quiz. And it has the new standard GGPB4 about interpreting graphs. Okay. This is not going to affect your grade, but it is very good knowledge to know going into next year. So if you've forgotten, AA similarity says that we need two angles of two separate triangles are congruent, right? Meaning they're exactly the same. So if I've got a pair of triangles and they've each got two angles that are equal to each other, then they are similar by AA similarity. Okay? The directions say that if state if the triangles in each pair are similar by AA criterion, so only looking for if these triangles are similar by AA. If they are, complete our similarity statement. If not similar, say not similar. So let's start off with number 1. Okay. Right off the bat, I see that B and V are congruent to each other because they've got those congruency marks. That's what that little arch in the angle means. And I've noticed that I've got vertical angles BAC, that angle right there. And I'm going to mark with 2 because that way I know it's not the same as angle B or V. And that angle is vertical to angle VAU. So those are congruent. That means I've got two angles that are congruent in my two triangles, so they are similar by AA. Now to complete the similarity statement, I have triangle ABC is similar to triangle, and ABC, we have to make sure that our letters, our parts of our triangle correspond. A corresponds to A on the other triangle, B corresponds to V, and C corresponds to U. Okay, that's it. Let's take a look at number 4. Here's another good example. So here I see two triangles that are embedded in each other. That means that the angle that overlaps each other, J, is congruent to itself, J. So I've already got one angle. And now I'm also given this angle measure of 62 degrees and 63 degrees. Those aren't equal. If they were both 63 or both 62, then they would be equal, but they're not. So we have not similar here. Okay, and you might be wondering, well, why don't I check K or E? And that's because if 62 degrees is not the same as 63, then E and K can't be the same either, because you can only have a maximum of 180 degrees in every triangle, and that doesn't change. Okay. Last one I think is a really good example is number 6. Okay. Remembering that these arrows here on the sides mean that those two side lengths, TU and MN, are parallel to each other. Okay. And things that we know about parallel lines is that they end up having alternating interior angles most likely. Okay. So because of alternating interior angles, I've got that U is congruent to M and T is congruent to N. Also noticing that we've got a vertical angle right here as well. So these two triangles are similar by AA similarity. It's kind of redundant to say AAA, since as long as you've got two angles that are congruent, the third one has to be congruent as well. So finishing off my similarity statement then, triangle B corresponds to V, U is corresponding to M, and T corresponds to N. Okay, so that hopefully is enough guidance to allow you to do numbers 2, 3, and 5 all on your own if you haven't done so already. Moving on to some of this new stuff, says using coordinates to prove simple geometric theorems algebraically. So we're looking at this triangle right here, ABC, in our coordinate plane. It says determine if the triangle ABC is equilateral, isosceles, or scalene. So remember, equilateral, that means it has all equal sides. Okay. Isosceles triangle, and I'm going to draw it out, means that it has two equal sides. And scalene is all sides are not equal. Okay. So just by looking at this, I can tell that it's going to be a scalene because all of those sides don't look the same at all. Okay. If you have a trickier problem where in the case you might see a triangle that you're not so sure and you want to double check, you can always use the distance formula. I'm not going to go super in depth, but I will link another video for that. So distance formula states x2 minus x1 squared plus y2 minus y1 squared. And that would be your distance, meaning you're going to take the coordinates maybe from A and then the coordinates of B being your x1, y1, and then x2, y2, and find that distance in between since that's at a diagonal and we don't really know. Okay. But that would be there for you as a very good tool. What is the slope of the line for side AB? So I'm looking at AB, and remember slope is rise over run. Okay, meaning in order to get from A to B, I need to rise up a certain amount and then run a certain amount. Okay, and the directions do matter. So upwards is a positive direction, and to the right is also a positive direction, just as you would see on your XY plane. So in order to get to the same height as B, I needed to go 1, 2, 3, 4 up. And then to get to the same X coordinate of B, I needed to go 1, 2, 3, 4, 5, 6 to the right, which is a positive direction. Okay, so your slope is 4, 6, and I expect that you can reduce this fraction to 2/3. And that's it for slope of side AB. Okay, you should be able to do the side for AC, but notice how we'd have to go down and right. Down is a negative direction, right is still positive. So you're going to end up with a negative slope. Number 4, the slope for side BC is kind of complicated. As you see, it's just a straight line going up and down. So remember that when we have a straight line going up and down, that's kind of like saying we have a lot of rise, but 0 run, right? It's not going left or right. And anything divided by 0, oops, I wrote that in the wrong place, I realized. Rise over 0. Anything being divided by 0 is undefined. Okay, so remembering that any straight line going up and down is an undefined slope. horizontal lines going left to right, those are zero slopes because then you'd have zero rise but a lot of run. Okay, and 0 divided by anything is 0. The next few are word problems that hopefully you should be able to interpret. If not, make sure you contact me or an email or stop by for office hours Friday, 9 a.m. to 10 a.m. Link is in your canvas. All right, good luck.